The topic is system bus timing. Here in system bus timing, you know very well about this T1 and T2. What is T1 and T2 in system bus timing? T is one clock period. So one clock period is referred as T. So one clock period is equal to T on plus T off. So for a single bus cycle, there are four T states. So T1, T2, T3, T4. Can you hear me? Hello? Hello?
Yes, sir.
Okay, fine. Okay. So T state is there. So four T states are there for a single bus cycle. So now let us see memory read timing diagram and memory write, IO read and IO write. So if you are familiar with this memory read timing diagram, then you can easily write memory write, IO read and IO write. So you are very well familiar about these diagrams. The first one is memory read timing diagram. So in this memory read timing diagram, we are going to use a clock signal here, address data, read. So with this, what are the signals we are going to use? Some more signals left here. It's not mentioned here. Can you tell me any one of the signal which is used here in this memory read timing diagram? ALE, very good, very good. ALE. Then many answers. One important signal is missing here. What's the signal? My title is memory read timing diagram. So what is the signal missing here? Memory slash IO bar. Memory slash IO bar line is very important, right? That is missing here. So we are going to use clock, address data lines, read write lines, ALE, then memory slash IO bar. So my headline is, this topic is memory read timing diagram. So in memory read, we are going to use memory and we are going to read the data. So here my signal is RD bar and my pin is memory slash IO bar. So if I'm going to use here memory, what I have to do? What about this signal, memory signal? If I'm going to use memory here, what happens? What will happen to the memory signal? I have to lower the signal. Or I have to increase the signal for memory read. What I have to do here?
Low, sir.
Low. Memory slash IO. I have to give here low. Is it right? Memory slash IO bar. So IO bar is there. So I have to hide the signal because for memory, if I give memory slash IO bar pin 1, it means that it is a memory. If memory slash IO bar is 0, it means IO operation. So here, in the place of memory slash IO bar, I have to increase the signal level, not lower the signal level. I have to increase the signal level. Okay. So the first signal is clock, then address data, then read memory slash IO, then ALE. ALE will be high for a single clock cycle. It's normal for every stage. So now for memory read, memory write, IO read and IO write, clock, address data lines, then ALE. These three signals are same. So we are going to change only RD bar, WR bar, IO slash memory bar based upon the question. If the question is memory read, I'm going to make this read bar line low. If it is of write, I'm going to change it as WR bar. Instead of changing diagram, I am just going to change here WR bar. That's all. Okay. And in the place of IO read operation, I am going to use here memory slash IO bar. So I am going to lower the signal level instead of making the signal high. I am going to lower the signal. That is, I'm going to make the signal low for IO operation. Right? The signal, if my signal is memory slash IO bar, so in this signal memory slash IO bar, I am going to lower the signal for IO operation. For memory operation, I am just increase the level. That is, I'm going to make the signal high for memory operation. That's all. So if question is like this, memory read. So memory, for memory case, I have to make the signal high. For IO operation, I have to lower the signal level. That's all. That's the difference. For read and write operation, just change. For read operation, just change this RD bar. For write operation, just change this to WR bar. That's all over. And remaining thing, everything will be same for memory read, IO read, and IO write operation. So timing diagram is there. Just draw the diagram and explain the concepts clearly. Next is wait state. You should know about this wait state. Wait state is an extra clocking period inserted between T1 and T2. That is between time T1 and T3. We are going to insert an extra time called wait state TW. It is inserted because in order to lengthen the bus cycle. Why have to and why you have to lengthen the bus cycle? Why you have to lengthen this bus cycle? Why you have to increase this level here? TW wait state, because while data is going to be transmitted from slower memory and IO components or IO devices, so it is not possible to transmit data in a sequence manner because IO memory is of slower compared to our IO device. So in order to transmit data from T2 through T4, we are going to insert a wait state. So the wait state is inserted between timing T3 and T4, sorry, T2 and T3. That is called as TW, that is wait state. So wait state is inserted between T2 and T3 in order to synchronize the speed between memory and IO components. Okay, can you understand this wait state? Can you hear me?
Yes, sir.
Okay, so wait state is a state that will insert a waiting level or wait state between T2 and T3 in order to compensate the speed between slower memory and IO component. That's all. Next, ready. So the ready input is sampled at the end of T2. So this is my T2. This ready will be sampled here at the end of T2, and again, if necessary, in the middle of TW. So in the middle of TW, this ready will be sampled. If ready is 0, then TW is inserted. So if my ready signal is 0, why you are using ready signal? What is it for ready signal? Ready, where you use this ready signal? Where you use this? I think yesterday also we discussed about this ready signal. Where we use this ready signal? Any answers? Hello, can you hear me? Hello, Dhanvisha?
Yes, sir.
Hello.
Sir. Yes, sir.
Why? What is the need of ready signal?
Okay.
What is the need of ready signal or ready pin? So in order to what? Memory, that is microprocessor, and my printer is not matching speed. The speed of the printer is very low compared to microprocessor. So in this case, we are going to use this ready signal. So that's why we are using this TW state, that is waiting state. TW state is inserted in this case. Okay. Next is my basic configuration. So in basic configuration, we are going to say about minimum mode and maximum mode. So in minimum mode, yesterday itself we discussed about this. What are the pins available in minimum modes? So just explain the pins and just draw the timing diagram for minimum mode. This is the timing diagram for minimum mode. And the same thing for maximum mode. Just draw the timing diagram, the block diagram for maximum mode, and explain each and every pins. Okay. Next is multiprocessor configuration. What is multiprocessor? What is multiprocessor? What is multiprocessor? So in multiprocessor, microprocessor is going to connected with another processor. So what is the other processor? What is the name of the processor? Microprocessor will connect with the other processor. What is the name of the other processor? Can you guess the name? Because microprocessor cannot perform some operations. In order to perform that operation, we need some extra processors. What is the name of the processor? What are the jobs which is not been done by the microprocessor, which is done by some other processor? Can you name the processor? I think you all forgot about this. What is a coprocessor? What is the function of a coprocessor? What is the function of a coprocessor? So microprocessor, it is not possible for a microprocessor to perform what operation? Floating point operations, right? It is not possible for 8086 microprocessor to perform the floating point operations. So in order to perform this floating point operation, we are going for a coprocessor. The number of a coprocessor, IC number of coprocessor is 80. 8087, right? Co-processor. So multiprocessor configuration, we are going for a co-processor 8087. So your microprocessor will communicate with this co-processor, okay, in order to perform some extra operation which is not done by 8086. So it is not possible by the 8086. That can be done by 8087. Okay. So in multiprocessor configuration, there are three types. One is co-processor, closely coupled configuration, and the last one is loosely coupled configuration. First is co-processor, then closely coupled and loosely coupled configuration. Okay. So both co-processor and closely coupled configuration, both are same. We are going to change a small change will be there in these two cases, and this loosely coupled is different compared to these two cases. The first one is here. The coprocessor and closely coupled configurations are similar uh, in that both 8086 and external processor shares both memory, IO system, bus. That is, all the buses will be shared by these two, and clock generator. And a single clock generator is used by this coprocessor and closely coupled configuration. Okay. So this is a process takes place in my microprocessor. So while writing a coding, that is, I'm going to use a coprocessor. The coprocessor is going to connect with the microprocessor, right? Actually, we are going to write coding in a microprocessor, 8086 microprocessor. While writing coding here in microprocessor, the coding which is used for 8087 is also written here in the same 86 microprocessor. So how the coprocessor knows that instruction meant for this 8087? Here we are going to write in 11011 at the MSB of a instruction. Before the instruction of 8087, we are going to insert this code 1101. If this instruction if this code 1101 is read by the coprocessor, this 8087 coprocessor, then the instruction will transmit it to this 8087 coprocessor. Then the coprocessor will perform the microprocessor will give the address bus, data bus, everything to this coprocessor. So the coprocessor will perform its operation. At the end of this instruction, the coprocessor will give this control to microprocessor. So by sending a high level signal to this test pin, the processor is shown here. So this is a process takes place in coprocessor. So this is my 8086 and 8087 instructions. So while executing the instructions, we are going to give an instruction called escape. So once escape, that is the code for escape is 11011. So once this instruction is read by the microprocessor, that is coprocessor, all the control will be transmitted to this 8087 coprocessor. Then at the same time, the coprocessor monitors each and every instructions. So once this escape instruction is read by this coprocessor, all the instruction will be transmitted here, and the coprocessor will execute the instruction. After executing the instruction, the coprocessor will send a test pin. Once the test pin is high level, then all the control will be taken by the microprocessor, and again the coprocessor will check for any escape instructions there in my microprocessor. So this is a process takes place in coprocessor. The diagram for coprocessor, this is a diagram for coprocessor. The same diagram is used by the closely coupled configuration. So here 8086 process there, coprocessor there. Here this 8086 and the coprocessor shares the control bus, memory, and IO device. So all are shared by this 8086 and coprocessor. The same block diagram is used by both 8086 and the coprocessor. Okay.
Sir,
Are you there?
WC class attend பண்ணு சார்.
ஓகேம்மா ஓகே ஃபைன். தேங்க்யூப்பா. இது அட்டெண்டன்ஸ் மட்டும் எடுத்துக்கோ. அட்டெண்டன்ஸ் மட்டும் பார்த்துருக்கோம். ஓகேவா? ஓகே தேங்க்யூ. ஓகே.